Hello everyone, we're back again. This is the second part of the notes for 1.2. On the first part, we looked at the 8 parent functions. We noticed nothing was added to them, or subtracted from them, or multiplied or divided by them. They were just the parent functions, plain and simple. But I want you to consider 2 questions. What happens if we either multiply or add something to the parent function? How does that affect the graph itself? And how does that affect, and what does it make the equation of that graph look like? That's what we're going to look at now. We're going to consider the quadratic function, okay? Okay, as you know, this is a parabola, and this is the parent function. The function on this one is f of x equals x squared. Okay, that's the parent function. So, let's take a look. What if I change the parent function? Take a look at this one. This one seems, when compared to the parent function, this one seems to have gotten very narrow and is stretching upward. This one looks like it has widened and is leaning down toward the x-axis, so it's like it's shrinking. Kind of like a shrinking violet. If you're thinking about a flower, it kind of just goes away and just wilts down. That's what that one's doing. Looks like I made some extra marks here on the board. Let's get rid of those. Okay, back to the lesson. Okay, so this is the form of the equation in function notation. So another way to look at it also is in vertex form, and that would be g of x equals a x minus h squared plus k. Now you're saying, Miss Norman, where did the h and k come from? If you remember back in Algebra 1, when you learned vertex form, we found out that when the vertex of a shape moves, we use this particular form of the equation. The h and the k represent the x and the y that we normally use for our vertex. So h is the horizontal change and k is the vertical change, just like x is horizontal and y is vertical, okay? So let's take a look at the difference here. We have a stretch here, so it's moving up. So this tells me that a, the number in front right here, is getting larger, okay? So in this case, we know that a is greater than 1, okay? Notice my a in front of the x squared on the parent function, it is 1. So when it gets bigger, it starts getting narrow, more narrow right here. So let's take a look at what this might be. We could call this one g of x, so we're going to call this one h of x. And these are just different names for functions. It's no big difference. G of x, f of x, j of x, b of x. You can name them with different letters. It indicates a different function representing a different graph, okay? So h of x here, we've multiplied this function by 2, which makes it stretch. It stretches up and away from the x-axis. That's where we get that term. In Algebra 1, you might have learned the term more narrow. Same concept, but it's stretching away. It's becoming more narrow, okay? We have a stretched, this one is being stretched by a factor of 2. In other words, it's being multiplied by 2. It's being stretched 2 times up. If you put a 4 there, this would even be more narrow and going further up, away from the x-axis as it came in. Instead of being down this way, it would come more up this way. Okay? So that is what this equation would look like. Notice, when a is greater than 1, you get a vertical stretch. Let me put that right here. So you'll remember that word also that goes with it. Vertical that's a vertical stretch. That's been vertically stretched by a factor of 2. Okay? Make sure you go back over there and take a look at that to make sure that makes sense to you. Now, let's take a look. Look at this other one right here. We notice this one has gotten wider, okay? That means it is starting to shrink, all right? So if this still is f of x equals x squared, our parent function, what has happened now? It's become wider. In this case, our a is now less than 1, but it is also greater than 0. So it's a fraction. If a number falls between 0 and 1, it is a fraction, a decimal. Okay? So that's what we have here for our a value. So on this particular equation, we have a shrinkage, or say you may say it was shrunk by, and it's a vertical shrink also. All right? So we want to say that, let's see, I have a h of x. Let's go, let's just call this one b of x. B of x representing this graph as opposed to the parent function right here, 0.5x squared. That is a decimal right there. So now my a is 1/2. When a, what's in vertex form, that's the number in front, when that number is less than 1, greater than 0, in other words, we're not saying negative. We haven't gotten there yet. We're going to do that in a little bit. But when it is positive, but between 0 and 1, the graph will will shrink vertically. Okay, it's like it was up tall, and then it comes down, it's shrinking vertically. So this is a vertical shrink let me redo that. That doesn't look too good. There we go. Shrink of 0.5. So we have a vertical shrink of 0.5, meaning we multiplied the x squared, which is your parent function, by 0.5, and the graph shrunk from being up here to being down here. Okay? Make sure you go back over that again, take a look at it, make sure you understand it, okay? So now, let's take a look at another possibility. I think I'm going to do it on the computer over here to be a lot easier. Let's scroll up. There we go. All right. There we go. Something a little different here. All right. Again, we have our parent function. Okay? So this is f of x equals x squared. Okay? Notice my vertex is at 0, 0. All right? So what has happened here? You probably said it flipped down. It reflected over the what? X-axis. That's right. There's a reflection over the x-axis. So let's put that down right here so we know. We've had a reflection, and you guys understand the concept of reflecting. When something reflects, it's like when you look in the mirror. You're not seeing, you're seeing a image. You're the pre-image, and you're seeing an image in the mirror. So a reflection is what it does when it falls down over. This is the original, then it falls down over the x-axis. So this is a reflection. And again, y'all forgive me for my handwriting. I guess I can't fuss at you guys too much about yours, huh? I'll remember that. I'll keep that in mind. So a reflection over the x-axis. And that is AXIS. This pen doesn't like me today, I don't think. Okay, so let's take a look. What's changed in this is the A in front of the X. We know when it's nothing in front of it, we know it's understood 1. That's the parent function. But what happens when I go, or when I actually write g of x equals negative x squared. So when a is less than 0, forgive me, less than 0, the graph is going to flip down over the x-axis. It's going to reflect and go down. You'll notice the points on these will line up just the same. This is 1, -1. This is 1, +1. So the points are reflected on the other side of the x-axis. So that's how when it goes down, you know there's been a reflection over that x-axis, okay? And if all the points remain reflected the same, you know that nothing's been added to, or nothing's been multiplied other than a 1 and a -1 in front of your x squared, okay? So now let's look at there we go. All right, now let's take a look at what happens to our parent function when it looks like this is shifted up and this is shifted down. That's something we haven't seen before, so let's take a look at what's going on there, okay? So again, we have our parent function. This is f of x equals x squared. So, what would cause the function to shift upward? Okay? This is going to be called a vertical translation because you see here it moved up and this way it moved down. So we're looking at a vertical translation. Vertical translation. And translation is just movement. When something is translated from one point to another point, it's just been moved, okay? So, let's take a look at this. When you add something to the function itself, okay, that's going to shift it up or down. So, the equation for this particular one, we notice our vertex here was 0, 0. Our vertex here is 0, +2. Okay? So I've added 2 to my function. So my function notation is going to be g of x equals x squared plus 2. So when something is added to the x squared out here, you're going to have a shift either up, added, it's going to be up. And then if it's added in the same place, if it's shifted down, it's going to be subtracted. So here would be h of x equals x squared minus 2. So when something is added or subtracted on the outside of the x squared, it's going to either shift up, +2, or down, -2. So we've looked at now a vertical stretch, moving up. That's when a is greater than 1. We looked at a vertical shrink. That's when a is between 0 and 1. We've now looked at a vertical translation where we've added or subtracted a number to the x squared. Okay? So that's another type of movement. And what you have to get used to is you have to know these well, because what if they put 2 or 3 in the same problem? When a graph might shift up and over and flip, you'd have to know what that equation was. So you need to be familiar with this information. Let me scroll it up again. So here's our last one. Again, we have our parent function. Y equals, excuse me, I didn't even put y equals. I went back to algebra 1 for a second, didn't I, guys? Let's try f of x. That's our function notation. f of x equals x squared, okay? F of x equals x squared. So, we know again, our vertex here is where? 0, 0. Okay? What about our vertex here? You're right, it's at 2, 0. And here it's at negative 2, 0. Okay, a moment of honesty. When I first saw these, like back in high school, when I took this, I assumed, just like with the vertical shift, that if I add it, it ought to go to the right. And if I subtract it, it should go to the left. But it does not. Let me explain why. Okay, let's take a look. We know in vertex form, our equation looks like this. F of x equals a x minus h closed squared plus k. That's the formula. So when I put in an h, which is the same thing as the x, hk, xy, when I put in an h and plug it into this equation, that's going to tell me which way it should shift. So if I put in a positive 2, let's do that. Let's do a positive 2 so you can see what I'm talking about. So if I take, I'm going to call that one g of x. If I take g of x, I'm going to write it over here though. Okay, here we go. If I take g of x and I plug it into this formula right here. I don't have an a. A is 1. We know that. There's no number in front of it because it looks just like the parent function. But if I put in x minus, I'm going to plug in the h, 2, and of course k in this case is 0. So that's what the equation looks like. So for when it goes to the right, shifting to a positive side, the equation is going to have a minus that number. Okay? Think about it. I plugged in a 2. The minus is part of the formula. So when you plug in the 2, that doesn't change. So it's minus 2 for a right shift. Let's look at it on a left shift right here. If I plug in negative 2 for h, so if I have h of x equals, again, my a is 1, so parentheses x minus negative 2, that's right here, close, squared, it's plus 0 because k is 0. So how do we simplify this? Right, a minus and a negative make a plus. So we have h of x equals, parentheses, x plus 2, that's kind of messy, let me fix that. There we go. X plus 2 squared. So a left shift it looks like it's adding 2. Remember the 2 initially was negative, and the formula has a minus. So minus a negative gives me the plus, but it's a left shift because my vertex is negative 2, 0. Up here, it was a right shift, even though I plugged in 2 because minus 2 is the formula. So when you see it in vertex form and something is being subtracted from the x itself before it's squared, you know that's going to be a right shift. If something is being added to the x before it's squared, that's going to be a left shift. Make sure you write all these down, go back over them, review them. They are not hard to do at all. Okay? So this was a horizontal translation. The other one we did was a vertical translation. So this is horizontal translation, excuse me. This is a horizontal translation. So we learned about our parent function. We learned about a stretch, a shrink, a flip when A is negative. Then we looked at a shift up and a shift down, and now we looked at a shift to the right and one to the left. Go back over these and study these. When you do your activities and your work online, rewatch the video if you need to. Do well. See you next time.